As new people come into our industry and older ones leave, it's important for young professionals to gain insights from those who have gone before them. Welcome to Legacy Voices. Legacy Voices is a podcast series that gives listeners the opportunity to learn from experienced HVAC and smart building controls veterans who are sharing their hard-won wisdom and invaluable knowledge with the next generation. Now here is your host, Eric Stromquist.
All right, my good friend, thank you so much for doing this. Appreciate it. When I think of Legacy Voices, Ken, I can think of none maybe more profound than yours. We're going to give our audience your life story today. We're going to find out how auto was made. Let's start with, where were you born?
Edmonton, Alberta.
Okay, so that's cowboy country, right?
Yeah, a little more grain country. Calgary's cowboy country. It's just north of Calgary. Yeah.
Okay, I got you.
Actually, we were pig farmers. I'm a pig farmer.
Okay, there you go. So for people out there who might be thinking about taking up pig farming, what's the best advice you can give a pig farmer?
Go into the building automation industry. It is way nicer and definitely more lucrative.
Yeah, no, I hear you.
And it smells better. Even though
Yes.
some days you don't think it does, it smells better.
Oh, I bet it does. I bet it does for sure. Okay, so you're born in Edmonton. You're only child, or do you have brothers and sisters?
Yeah, and one of four. Two older brothers and a sister. I'm the baby.
You were the baby. Okay.
Yeah.
All right. I got that. That explains a lot. Okay. All right. We got a listener here. What birth sign are you, Ken?
October, Scorpio.
Scorpio. Oh, there you go. I've been married to a couple of those before, so I'm amazed we get along so well. I can. So walk us through. So early years, you a good student? Do you like to study, or what were you like as a teenager?
Disaster.
Yeah.
I basically came out with a grade 11 education, went off to tech school, took air conditioning because it was the first one in the book. Plus the other ones I was qualified to take were like heavy duty mechanic, and I knew what that was, or cooking, and I knew what that was. I had no idea what air conditioning was, so that sounded like a good one to try.
Okay. So were you like into mechanical stuff, cars and stuff like that? Or were you just having to farm so much that you didn't really get into the schoolwork so much?
We were in a very small school. We had 12 people from grade 12 to 9 kind of thing. So it was pretty...
Okay.
Yeah. Going to tech was a real open my eyes kind of thing to the world.
Yeah. Yeah. Got you. So you went to tech school.
And tools, to find out there was tools other than crescent wrenches and hammers.
Oh, yeah. Yeah. Well, that's cool. That's really cool. So you're at tech school and you're learning about air conditioning there?
Yeah. I took refrigeration, air conditioning, 2-year course. Basically, what it did is it gave you a 2-year apprenticeship. You could go into your second or third year of refrigeration mechanic. All my farm training made me not a good mechanic because I could fix almost anything with anything, but not a trades type person at all, although understood the concepts of it. And the course did a good job of doing that.
Okay, cool. So you get through tech school. What happens next?
First job was selling fans, pumps, infrared heaters, interesting stuff, and had enough knowledge to go out and do the service calls and things like that. Again, a rapid learning curve.
Was that with a distributor or?
He was a distributor. He had several product lines.
Okay. Yeah, that's
Thermal Engineering was a good name.
That's a great name for it.
Yeah, great name. Yeah.
You and I have something in common. I sold quite a few infrared heaters back in the day. We had Space Ray gas-fired products was our line.
We had Solaronics.
I know Solaronics. Yeah, that's a great product, right?
Yeah, actually in the far north, an infrared heater is trying to get a cat going in the middle of 40 below is nothing like an infrared heater to shine it right on the block. Actually, one of the fun ones, I went up to a place called Fort McMurray, which is north of Edmonton, and their infrared heaters weren't working, and it was typical minus 40. So I pointed out to them that propane turns back into a liquid at minus 37, so that might be your problem.
Yeah, well done.
The solution by the guy was to get a Taggart torch from a propane tank that he had in the heated space and take the Taggart torch and heat up the large propane tank.
Oh my gosh. Wow.
Unbelievable.
No, it was unbelievable.
Once he got the propane flowing, then we got all the heaters going, and so lots of fun.
So you were problem solving. So selling, was that difficult for you? Did the guy just put you out there and say, here are the products, go sell them? Or were you just...
I actually did.
Yeah, I got you.
And that didn't go particularly well because my next job helped a lot with that. Next job was with Johnson Controls. So
Okay.
with Johnson, and I came on as I think it was a service representative to start with, and then they sent me off to Milwaukee for a couple of months and tried to make a salesman out of me, which they got bits and pieces of it. So it helps. It's probably a lot of who I am is that training, both the training, the technical training, and we were actually, an interesting thing is way back then, we're talking in the 60s.
Okay.
They would actually record your presentations on video, and then you had to sit there and watch it, and everybody critiqued them, what you did wrong. So
that was pretty progressive for the 60s, because I suspect it was more like one of those old movie sort of film camera things that probably put it on the reel and played it, because they didn't have digital cameras back then, I don't think.
And that was done in the original Johnson office in Milwaukee, the old brick building. And
the
guy was still pouring the control valves. He'd dip up a big thing of brass and he'd dump it into the sand cast and cast the control valves, and then they would machine them. Yeah.
Johnson Controls has always been known for really good training. Some of these, Honeywell too, but Johnson particularly, I learned a lot from going to their classes. But the sales class, I think what a lot of people don't realize is that selling's like anything else. There's a process to it, right? There's a sequence you go through. And it's not really necessarily about trying to get somebody to do something they don't want to do. It really is about trying to help discover if they have a problem, discover a solution that works for them and make it work. It's in many ways not a lot different than a mechanical problem. Sometimes you got to get the propane torch out and heat up the tank.
Right. And actually having that practical experience when you're selling, I think really helps if you can relate it to something real.
Yeah.
And when I got into to actually selling service contracts, which is a lot like selling vapor.
And what way, Ken? Tell me about that.
Yeah, it's if you do a great job on a service contract, you never have anything break down. So therefore, are you really doing anything, or was there nothing really to be done? It was always complicated.
Yeah.
And trying to sell that to a rural school board, and you're asking for a price for the service contract that's greater than your maintenance budget. It was a tough sell.
Well, but so how did you pull it off? Any advice to young salesmen out there? Because we all run into that.
Basically, befriend them best you can and help them out. Actually, one of the main things is I had enough skills that I could actually make their system work. Typically, I got the call because the system was absolutely broke. The school was freezing or something like that. By fiddling setting a few pin valves and doing some stuff, and you could get it operating, and then you became like the local hero.
Yeah.
And then they said, if we get some money, we'll do some of this stuff. And they saw that some of the stuff had to be done. It was actually the same problem we've got today. His pneumatics was falling on these rural communities, and they knew nothing about them. And it was a lot of it was just education. Is that this is what the system does? This is how it works. But it was a big step for most of them. 8 times.
Yeah, no, but I think you're hitting on some timeless principles here. It's funny. I took a networking with a network expert talking about will you have people network or whatever. And one of his principles in the networked economy, but I think it goes back to what you're talking about too, was that givers get. So go first. And I think a lot of people are worried about that. But I think if you can help somebody out, first off, before you ask for anything from them, try to find a way you can help them. And then obviously having some technical ability in this field where they gain confidence in you because you've proven that you can do it. And I think all things being equal or close to equal, people want to do business with people they like. If you've been able to help them out, then they're more than likely going to like you.
I think that help was a big one. I remember a little story I switched over and I did a lot of training as to selling, because selling and training are pretty difficult to pull apart. You basically have to train the person to what it is you're trying to sell them. And the Yellowknife is in the Northwest Territories, and you have to basically fly into my sales area was from Red Deer, which is in the middle of Alberta, to Inuvik, which is in the high Arctic.
Oh my gosh.
To the West Coast. The people from Vancouver didn't come up. I had to go back over and right over into the Yukon. So I had a big sales area.
So you didn't have a company car, you had a company plane?
No, we would fly when we had to fly, but I put almost 100,000 on a car one year.
Wow.
And bumpy roads. So anyway, but the thing is to give these people the training they needed in the remote spots. They really appreciated that.
Yeah.
And to the point that they sent me down probably about 20 pounds of Arctic char as just a thank you gift to kind
Oh,
of
wow. That's so cool.
PWA arrived and
Yeah.
they said, "You got this parachute, you got to come pick it up." And I said, "What is it?" Arctic char.
How about that? That's
Wow.
great.
Yeah.
But you
You
know,
paid in fish.
yeah,
Better than the commissions.
I know, I got you. But it gets back to just the key principle. When I was on the road, the first thing I tried to do is, can I come in and train your people? I'd be like, well, we're using another vendor, whatever. Well, what about this? When was the last time you got training? And that was really, that opened so many doors, being willing to go in and do the training for free. But I wonder how that would work now, because it seems like so many people, I don't know that have the same effect. What do you think? Is we'll train you, we'll do a Zoom call together. Do you think it has the same effect, or was there something about being there in person?
Yeah, the internet has certainly changed the whole approach to that. And that was always my fascination with it when I retired to start automated buildings over 25 years ago. Yeah, so it's changed it, although I think I still see value in trying to assemble information for them. It's just such a quagmire, that's maybe not quite the right word, but it's close, of information out there now, and to try and pull out what you need. So I can't pull out what everybody needs, but I can pull out what some people need. And by organizing that on a page or creating a resource, I think there's still value. So really what we've done is what I used to do physically, we do virtually. And of course, now we're into this AI, which is just another dimension.
That's crazy. We're going to get to that, but we're going to cover Jane before we get to AI. Okay, Ken? So we're going to get there. But yeah, so when you think back on those early days, maybe the Johnson training, sales training, and those early days, what was some advice you got, or what is something you remember that you go, yeah, this is advice I'd pass on to somebody else from those days, or this is advice I got, or this is what worked, this is what didn't work?
I think one of my main mentors at Johnson was a guy called Cliff Badger, and he was a really great controls engineer as well as an engineer. And I would go and ask him a question, and he would ask me a series of questions. And I'd go away, and I'd try and answer all my questions, and I'd come back and, what kind of a system is it? And do they have this? Is it hot water? Is it steam? All the logical questions. And eventually, by asking those logical questions, I less and less had to go and ask him the question. By the time I asked myself all the questions, I had the answer. And that was always the problem. So I guess it's teaching you how to think, and teaching you what are the questions you have to ask. When somebody asks you a question, the first thing you got to do is you got to ask them a question. What are you talking about? Or are you talking about this? Or are you talking about that? And even more and more in today's world, we need to define what it is we're talking about. And once we both figure out what we're talking about, often the whole question just disappears, and we're now talking about what it is we wanted to talk about.
Makes sense. To me, it sounds like one of the things that Quiff was doing was teaching you how to troubleshoot. So
teaching you how to think, actually. No one actually organizes. That's even like tech didn't do that. And even the sales courses in Johnson, they didn't, the process of thinking, the process of problem solving, I think.
Yes.
Maybe that's it. I never had any course like that. And he just did a great job of that. And I completely trusted the guy. I think that's the other thing too, is your mentors, and that would probably be, to answer your original question, what is the greatest thing? The greatest thing is to have mentors that you absolutely respect, and you're just so comfortable. You go to them, and if they tell you to jump off a cliff, you jump off a cliff.
Yeah.
That's what it seems like a good idea. Yeah. So yeah, mentors are, and I've had just some huge mentors in my life. They'll unfold later, I think.
Yeah, cool. When you were talking about Quiff, it sounds to me like there's what is an old adage: you give a man a fish and he depends on you for life. You teach a man to fish and he becomes a fisherman. It seemed like, him teaching you how to think like that, that would have, just hearing the story has a great influence on me. When somebody comes and asks you for advice, you can either give them the answer, or you could ask them questions so that they can discover it for themselves, which it sounds like he was maybe doing some of that.
Yeah. The other thing too is not being, but then I entered a realm of engineers, and I had not gone to engineering school. And so the whole thinker, the bigger picture thinking was, I've always been, as a technician, you tend to be focused on some little portion of the problem, and you're usually quite good at it. In fact, the engineers come to you to ask you, how does this thing work? But how that piece works inside of the big puzzle. And in course of our industry, describing the big puzzle just keeps getting more and more complex.
Yes.
Where does the edge of the puzzle stop?
Yeah.
I've never found the edge of the puzzle after all these years.
Okay, so you've been out in sales. Now you're hanging out with engineers. How long have you been at Johnson before you started hanging with engineers? Or was that just going on all along?
You're right. Yeah, it was a relatively small office, probably 10, 15 folks or something like that. Then the other thing I got to hang out with was the service people. And I related to them. And a lot of times I was like the go-between. The engineers are saying those damn mechanics. And I think, yeah, you should listen to them. Yeah. They got some good stuff. That stuff you're doing isn't working.
Yeah, there's theory and there's reality, especially when pretty much anything. But okay, so now is Jane in the picture yet? Or she's okay. All right. So when did you meet Jane?
Kindergarten.
What? Oh my gosh, we should have started with Jane.
We didn't have kindergarten in those days because that wasn't. So anyway, yeah, we've been together for a long time.
Oh, Ken, I've heard of high school sweethearts before getting together, but kindergarten sweethearts also. That's all.
It was a small community.
No, I got you. Okay, so were you married at that point in time, or were you still dating, or when did you guys get married?
After Tech.
After Tech, okay. After Tech, before Johnson, before JCI.
Yeah.
Okay, yeah. I got you. Wow. Oh, Ken, I didn't know that about you. I haven't met Jane. I understand it. I can see her. She probably was a catch as a kindergartner and just got better as time went on.
Actually, after that, while we were at Johnson, we built a house on Beach and together. And then actually that was when I went to Milwaukee. So the house was half done and left her in the house with our first child.
Okay. Was that your daughter?
Yeah, the oldest daughter. Yeah.
Okay. Cool.
So anyway, that's all happened at about the same time.
All right. And I'm guessing you're in your mid-20s about this time?
Yeah.
Okay, I got you. So still young enough to think that the world's conquerable.
Yeah, for sure. Okay. I was just more amazed coming from the farm and seeing everything was just like, oh, wow.
Yeah, I bet. And you guys are living in Vancouver then?
Still in Edmonton.
Okay, in Edmonton. I got you. Okay.
Yeah.
All right. So you're with JCI now. How many years are you with JCI?
6 years to probably about 5-6 years.
Okay. All right. And what's next after JCI?
Actually, you hit on the thing on the JCI. They do amazing training, but once they train you, you're more valuable to everybody else in the industry than you are to them.
Yeah.
So actually what I did is I left and I went to work for a developer, and I looked after five buildings in Edmonton, 15-story apartment building and commercial 4, 6, 7-story buildings, and good portfolio, probably like a little over 500,000 square feet of stuff. So I became like an owner, saw everything through the developer's eyes, and he just had some major problems that needed to get fixed. And trying to separate the problems from control to mechanical design is they're often one and the same. So try and fix all of that, and just kept picking away at the buildings and actually got them working. And so it was good fun. I learned a lot. I got to learn what it was I was selling and how hard it was to actually do that, and just the pressures of operating a building.
Yeah.
There's a good story there. In the 15-story office building, one of our disgruntled tenants decided to leave his apartment at 40 below and left his door open, slid his glass door open on the patio.
Oh, no.
And froze up the hot water. And so the hot water is cascading down this 15-story building.
Oh my gosh.
I get there, I had to beat my way through the fire department to get there. They thought it was a fire, but it was, of course, the hot water hitting the outside. It was cascading down.
All kinds of smoke, huh? Yeah.
Yeah. So actually, that was a pretty neat experience, because what happened is you would not believe 15 stories of people jumping to action and getting wet vacs coming out of everywhere, and people pulling up water and trying to shut up pipes and trying to re-bring up a system in the middle of the night.
Oh my gosh.
That's when I left facilities management, and I decided it's got to be a better way than this.
Okay. Oh, I hear you. Listen, I do want to ask you a question, because obviously a lot of the people in our industry, they deal with developers and people that were in similar type positions. And although I suspect it's changed some, you mentioned I didn't understand the pressure that developers were under. Is there anything you could relate to our listeners about that? So when they're talking to developers, maybe have a better understanding of what they go through?
It's back to that big problem in the construction industry is broken. We build everything for the lowest buck. And so you don't have shut-off valves where you have it. There's no safety. There's no backup. Even they skin everything. Would have to operate the thing at higher than normal pressures just to overcome other mechanical problems and the lack of heat, and didn't have enough heating surface in cold area because the building leaked too much. And yeah, there's just a whole bunch of things you got to solve. Reality bites.
No, I get you. And my guess is too, one of the things is then the people you're working for don't want to give you any money to fix any of it. I mean, that's what we got you for. You fix it. You figure it out. But no, I need this much money. I need a new chiller. You need a new what? I don't think so. Figure out how to make that. Is it that kind of thing?
Yeah, it's worse than that. It's the embodied mistakes. Once this stuff's built and put together, you got problems that you have to work around every day kind of thing. And you can't take the build. Money can't even fix it because well, a lot of money could rebuilding the building. But
right.
It's when you don't have enough radiation surface area or something like that. That's and of course you're operating in an extreme environment too. Edmonton can be pretty bitter some days.
No, I got you. Okay, anyway, so you say, okay, enough of this. What's next?
There was an ad in the paper for an assistant energy analyst for I also halved the energy in this developer's buildings while I was there. So that caught some attention.
How did you do that?
Make them almost work the way they were supposed to.
Oh, nice. So you just went in and you tuned the systems up and got them working how they were.
It's just bizarre. You get just fixing stuff that's broken and just doing what our industry is all about, trying to make this stuff work. Anyway, I got that position, and it was a contract position, which I liked. So it was originally a 2-year contract. And what they wanted is they were starting into computer simulation, and that sounded interesting. They had 2 positions. They had an engineer and an engineer support assistant energy analyst is what they called it. They had an energy analyst for the province of Alberta, and then they had an assistant. And their project was to basically explore the domain of computer simulation. And so we did that. We used the old Merriweather program. It ran on cards in Ottawa. And so we would basically use all our calculation skills and calculate the buildings and put all of that on there, round it in, had this dynamic calculation. Then we would change something and see if the energy went up or down. And we knew the answers, but it was nice to see it. And the simulation taught us a lot of things. So we worked with these simulations, and then they gave us 4 or 5, maybe 5 major buildings like courthouses, tech school or vocation schools. What was the other one? Had 2 courthouses, 2 vocation schools, something else, can't remember. But anyway, they were relatively large buildings, like 250,000, maybe 500,000 square feet. And big chillers and stuff. And so I was comfortable with all that equipment, and they were not. So it was nice with this thing. And they basically just left me alone because they had no idea what it was I was doing. But again, we pulled the energy down 50%, and we credited it to simulation, which some of it was, but certainly not all of it. It was just making the systems work the way they were supposed to.
Supposed to, yeah. No,
bizarre too. Actually, it's some of the stuff and actually one of them had oh my God, the original Honeywell
Delta system or whatever it was called.
The one before that.
The Unix or something like that.
I think it was called. It was basically one of those real old systems like that. So actually, and the other one said no automation at all, and nobody knew how to calm down a chiller when it started screaming and stuff. Anyway, so it was good fun. Traveled around, and then I was working.
Well, hang on a second. I just got to make a statement. What occurs to me is, with all this analysis you were doing and all these simulations, you're like the grandfather of the digital twins, aren't you? Think about it. That was essentially digital twins back in the day.
Yeah, very much. And actually, all my mentors from that point on have a background in simulation.
Okay.
Probably one of the most significant mentors I met at that time was a guy called Don Holt of Nova Engineering, who became the president of ASHRAE International.
I remember that name,
Don was a young engineer, just slightly older than me. And one of the simulations we did, which was epic, was we did a simulation of a bubble over a northern city north of Fort McMurray. And the idea we put this bubble up, and there'd be enough solar that if we could keep the wind out, that we can actually raise the temperature to almost like a Mediterranean level in northern Alberta. And then we would use it for the construction. This bubble was 60 acres, was the size of it.
And when you say bubble, is like a big balloon or?
Yeah, like a tennis.
Okay, I got you. I see what you're saying.
Like a tennis thing, but a really big one.
Yeah,
and
wow.
It had a flipping skin, and so it was a fun project. And so we used computer simulation to basically determine if we could heat the ground enough to
make the bubble rise.
Make the bubble work and keep it above freezing. And we would throw in some heat, and how much pressure did we need how much fan did we need to have to keep it up, and all that kind of stuff. Anyway, energy was not a really big problem because that's what they're doing. So if we had to burn a little carbon back in those days, we would do it to keep it up.
How cool.
Anyway, so that was kind of fun, and that was the project we cut our teeth on. And that was actually after I left being the assistant energy analyst. So what happened there is another story. Is I was in one department of the government, which was Public Works, which had basically done this pilot project, and all of the buildings were maintained by a division called Government Services. And they stood up and actually in the local legislation, and they beat their chests about how great this project had been and how successful the computer simulation was, and that we should invest more money in that. And Government Services jumped up and said, "Thank you very much for doing the research, but it's definitely in our bailiwick, and we will turn it over to our energy department," which they quickly discovered they didn't have an energy department.
Sounds like governments to me.
I'd been working with their people, actually, and I'd been in their building so much they thought I was working for them, but I was actually working for the other ministries.
That's funny. That's funny.
And, so I was a natural guy to come over. So I said, "Well, just pick up the contract." They didn't want to do that for political reasons. So they said, "Why don't you start a business?" And so that was the start of Sinclair Energy Services.
Oh, interesting.
1975.
Wow.
1975, we started SES. And my prime client was Government Services then.
Okay.
And then my job, in addition to doing what I was normally doing, just optimizing buildings and using simulations, we took on the education thing, and we did the traveling energy show. You would have loved it. We roll into town, a carnival act, and we would basically go into these small communities and try and help them change the government buildings and schools and things like that. So it was good fun.
It was the Ken Sinclair and P.T. Barnum rolling energy show. I like that.
Actually, our logo was exactly that. It was the traveling energy show, and we had a manual and everything. It was good fun. Anyways, it was great fun, and we got to see even more of Alberta, because that included southern Alberta and all of Alberta, kind of thing, because it was driven by the province. Anyway, so we did that for a while, and I still had some spare time working with government. They always not that demanding. I would do simulations and other stuff, and I got involved with the University of Alberta, who was building at almost the same time in 1975 a first ever direct digital control system. And basically they called it the RCMS, the Remote Control Monitoring System.
Okay.
And it was built on the ashes of the old, everybody had tried to pick up, it's a pretty large campus, it's about a 15 million square foot campus, and everybody tried to pick up with control point adjust and hybrid pneumatic and electronic and all that early logic stuff that didn't really work. And this was the first thing. So we picked up and we took all the sensors that they had, and it was actually originally a power system. I think something like a 570 or something that it had not worked out all that well. And they stopped construction on it, and we took over and we built the first DC system of the time. And we used DEC computers for our head end. And we used Modcom panels, which we took from the cement and glass industry.
Wow.
We started building DC, and we had the concept of direct digital control in our head. And they sent me off to a few computer courses so I could get my head a little better around it. My purpose was to interpret the existing pneumatic strategies so that they could be turned into software.
Okay. So you would write the sequences or tell them what the sequences need to be?
Yeah. And the other thing is, when I was a service salesman for Johnson, my biggest client was the university. So I knew their buildings really well. So it was a sort of a natural fit again. So I worked at that, and that was like an earth-shattering, earth-changing project. And I kept loving it and slipping out of more of the government services training and stuff. Although all that stuff interlocked and fit pretty well. And again, I had at that point, a guy called Ron Burns was the director of energy for the university, which had never, ever been before that they had. This is 1975. The energy concerns that were at that time were big in the press. And anyway, we basically built this system. We had...
Hang on, it's got to be like the first DC system in Canada. Maybe was it in the world, or was it just in Canada?
There was a couple of them involving. We had about 4 or 5 across. No, not that many, about 3 maybe across Canada that we were all just building it. What we were doing, we're looking hard at the first people to do this was the glass industry, because they needed to have real close temperatures.
Yeah.
And the consequences of not having those temperatures, that you got a bunch of glass that doesn't mean good. So you could afford to buy a $200,000 computer to control this thing. And so it evolved out of that. And then the next people to pick it up was the concrete people. Because when you're making concrete, if you don't know what the relative humidity of the sand is, because it eventually determines how much moisture is in the concrete. So they have to measure all these variables dynamically, because it's all running down the conveyor belt and actually getting inside of the concrete people. So that's where, in my mind, that's where RealTime BC came from, was that industry. They came with us, or when we started looking at them, they were all industrial controls. And of course, we then got introduced to ISA and ISA standards, like the transducers were like 10 pounds, and they cost I think it cost $1,000, the first transducers we used. And so everything we touched, we had to rebuild, because we couldn't afford that much money to build them for our purposes. So we created almost every one of our devices. They were all using RTD back in those days. We actually stayed with RTD in the early stages. Later on, it was actually the Vancouver guys that moved over to Thermistor. And it was fun times.
Ken, I had no idea that you had done all that. That's really amazing. It seems like it fostered the innovator in you, right? And it's like Canada's Steve Jobs, maybe, or something like that. Okay, so you get that bad boy going, and then what happens next?
Some of the key people, a guy called Jack Meredith, who was a close friend and an engineer on the project, he got a new job in BC, which the goal in Alberta is to get out of Alberta and get somewhere a little bit warmer in Canada. And the only place that is BC. Actually, we call it British California in Canada. So
nice.
British Cal. So basically, to get out there. So he got a job with the BC, which was the British Columbia Building Corporation, and of course, he had a lot of success in saving energy at the university. Of course, the other thing is, at the university, we saved. The DC was a huge success. The biggest thing is the university had a central chilled water plant down on the North Saskatchewan River. And at that time, we had, 8,000, 10,000 tons of cooling down on the river. Edmonton, although it gets really cold, it also gets really hot. So you have both sides of the coin. And they had like miles of tunnel. And then all the buildings were connected. And in the winter, for chilled water, they just took cold water out of the river and ran it through. So you can imagine there's at least some hydraulic problems when you've got high-rise buildings above, and the river's about, a couple hundred feet below the university too. So we had hydraulic problems. And as soon as we put the DC system in place, lo and behold, a lot of the buildings, the chilled water was going backwards through the buildings and stuff. So we actually started solving some of those hydraulic problems, and solving those hydraulic problems saved incredible pumping, And we actually were able to bring on whole buildings on the existing chilled water plant without adding any extra cooling, because we made it actually work the way it was supposed to work. But again, DDC was the key. Once you put a trend in front of somebody, that everybody can see that, oh my God, look what's happening.
Yeah.
Before those days, we couldn't do that. Nobody had ever seen this stuff. Oh, the other thing I love is the old terminals. The resolution was a quarter of an inch on the screen. So you had fans that were blop, blop, blop. But
oh my
that being
gosh.
said, we had the industrial controllers and the PID loops, and all of that stuff was all there on the screens. And
well, again, put this in perspective for me. How many people in Canada are doing this now? It sounds, is it just kind of you and your band of merry inventors, or is this sort of blossoming them up all around Canada? The DDC.
Well, at the same time, we ran into this guy. You might have heard of him, called Mike Newman.
Yeah, we know Mike.
And this guy he's a guru from the States who's working at Cornell, and he came up to see what we were doing, and so that was fun. So that's the first time I met Mike. Was on site at the university, and of course he's on the BACnet thing. He's going to make all of the Big Four's systems that talk a common language, and we whispered in his ears, none of them work. Run.
Oh, wow. So he was, even back then, he was thinking about how we could get everybody to talk the same language. You could make some mess.
Thought that was, and that is certainly part of the problem. But the bigger problem is at that time, nobody was doing DDC. They were all CPA, and they really didn't want the BACnet thing either. They wanted to control the campus. So it was like we're all fighting to control the campus, which is exactly the same problem we had. Is we had all the vendors, and I had lots of insight into that because I was, of course, the Johnson fighting to get my little share of the. And actually, it wasn't a Johnson job, but it was totally, but it was close. It was the bulk of the university was Johnson.
Yeah, put in perspective for our audience, back in those days, a Honeywell system did not talk to a Johnson system, did not talk to a Siemens system. So the game back then was you just went on bid day and then you pretty much own them, right?
Yeah, and the other thing is it's early days. So basically, everybody's offering you a hardware logic system with CPA, if that means anything to anybody. CPA is control point adjust. Hardwired logic is not really a computer. It's just basically switching electronic sensing, and you can imagine the switching problems. It's like the old telephone exchanges, and even worse because the equipment wasn't nearly as robust. So anyway, yeah, it was interesting times. And in the final analysis, everything ran with pneumatics. When the computer crashed, or I should say, if the computer was up, was probably a better definition. It was very seldom that. So we learned a lot about that. There's too many stories in there, but another story was that came out of the university job that really fashioned the control industry in Western Canada, was the concept of a standalone panel. And that the cement people had been using that. And so they didn't want to take a deck computer and put it out in the rock storage yard. And so they wanted something that would look like a control panel, but functioned like a computer. And so a company called Modcom back in those days made a panel like that for them. And we used to buy those Modcom panels. And then what happened is when our development people saw it, they said, wow, that's really not that complicated. We can make it for a quarter of the price and make it more robust and much better. And so they did, in fact. And so we had even a local product that was developed for that. So then this ties into the transition to BC. So I started doing some work for British Columbia Building Corporation. And my first job was to convince them that computerization was something they should invest in, because the ones they had were basically just dogs. They basically had incredible service contracts on them. They virtually didn't do anything. They had security put on them, which didn't work either. And they were just a disaster. And the first task was I couldn't rip them out and replace them with something I knew worked. I had to make them work. That was a real challenge. So we had to make the Delta. We had to make the Delta work, but we did.
Wow!
And the Delta worked. It's, if you don't mind programming in zeros and ones, it could do amazing things. It was a true computer. Actually, it was in my mind, it definitely was better than what Johnson was doing at the time with like the early JC80s and stuff like that, which were anyway. So my job was to ferret those things out, and then it gained some credibility just because of our DC stuff. We picked up the community on the West Coast was, British California, where they were basically thinking in microprocessors. And so they said, why don't we do what you're talking about with microprocessors? And so when we went out using a concept called a request for proposal, and some of the local vendors actually then bid. Actually, the product that we pointed at that was the model of all of this was the Powers SCU, standalone control unit.
Okay.
I think they called it.
Yeah.
And,
MC Powers. Yep.
Yeah. And I don't know if you remember it was the program was backed up on a cassette tape. And
Oh my gosh.
which we had one of our local people modify so we could actually back it up. We could back it up on a computer, but they couldn't. So had to hack some of this stuff just to make it work. Anyway, so the SCU was a good thing. The other thing at that time, Powers was using DEC, which seemed to be a good head end, if you didn't mind the 4 feet of manuals that came with it.
Wow. Yeah.
Anyway, so as we started and the jobs we had with BC, a lot of them were, there was a mixture. But there was they had 700 buildings, but a lot of them wouldn't make 50,000 square feet. That being said, Robson Square, which was a project I cut my teeth on, was 1.2 million in one building, 3 blocks of Arthur Erickson design, basically a park with a building underneath it. And it has chilled water storage, which never worked, and we got to play with that and make that work. Nice. It was 1 million gallons of chilled water storage. Got playing with that, but again, we had a Johnson system, and we needed to, it just couldn't do what it is we needed to do. And so again, we went out for requests for proposal, and of course, by that time they had new systems, but their systems were fairly costly. The local companies actually bid, and it was scary, but they came in for about a tenth of the price of the other one, and we figured they would lose their shirt and go down, but they figured out how to do that, and that turned into the Delta company.
Wow. Okay, so that's Delta Controls as we know them today.
It was ESC back in those days.
Okay. Wow. So they came in low price and said, we're going to make it work, and you guys are thinking, good luck.
Yeah, and actually what they did is they slid their new microprocessor panels into. And we've been into 3 or 4 years of evolution on the West Coast by that time, and they were starting to get pretty solid by that time. Anyway, what they did is they built edge connectors that fit right into the Johnson wiring.
Okay. So
they could actually just slide the panel in, plug in the thing.
Oh,
so the whole job went a whole lot better than we would have imagined. So again, innovation, good stuff. Anyway, we pulled it up, and it started working, and anything that didn't work, they were pretty motivated to make work as well.
Very cool.
And the project just kept going and growing, and it creeped over to the next building, and pretty soon we had 3-4 blocks of this stuff all connected together in downtown Vancouver. So anyway, that's where all that came from.
Very cool.
Yeah, and then there was another company at the same time was building product, and their fit was better in the smaller buildings at that time. And it was originally called a Burke system, and it turned into the Reliable system.
Okay. Reliable controls. Okay. Yeah.
So both of those, grew up with those guys. And at that time, then they all discovered BACnet and Mike, and BACnet became good for them to push their companies because it was easy for them to do. They didn't have standards, so they just basically adopted the BACnet standards when they were building their products, and every product they built got better BACnet standards. Yeah. Actually, if you trace back the history of BACnet, you'll find people like Carl Nelson of Delta in the early days working with Mike, and Roland Liard, the owner of Reliable, and Raymond Ray, all those guys. It's ironical that the BACnet is, a lot of it is controlled from West, the people that actually making it happen. In fact, I just wrote an article on that, on BACnet, the history of BACnet. It's on the site. I'll send you a link.
No, which we definitely check. It's interesting, Ken, because here you basically had the big 3 or 4 companies, Honeywell, Johnson, and Siemens, because it was just complicated. But it sounds like the third parties, if you will, the Deltas and the Reliables, and I guess Solidigm was from up your way too, I think, and they were the ones that really opened it up to more competition, it seems.
Yeah. The Andover, we struggled a bit with Andover in the early days as well.
Yeah,
the drum programming was the deal breaker for us on that. We chose to go with an if-then-else control language, which was a variance from the rest of the world too. You all were all using like the Tritium and the basic graphic program.
Right.
We didn't think that was so. We thought that was too difficult for the operators to understand. We very much wanted the operators to understand what it was. If the fan is on, then open the damper, blah, 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 and allow controller 6 to control the
all right, makes a lot of sense. Okay, so now you're this innovator hanging out with all these really innovative people in Canada doing all this cool stuff. At what point did you decide to hang that up and start automatedbuildings.com?
When I retired.
Oh, okay. So you were doing this, the innovative crew for how many years? 15, 20, 30 years?
25, yeah.
25, okay.
Yeah,
and then,
25 years with SES.
Okay.
35 years before that in the industry.
Okay.
Over 50 now, well over 50 years in the industry.
Wow. And so I'm surprised you retired.
That's probably an interesting story. It's when I retired. Of course, I'm not good at sitting and doing nothing. The internet was just happening. It's 1999. And so we retired. We'd done very well, SES. And actually, there's a couple of good stories there. One is SES, the guys at BC asked, okay, so now who do we get to do what it is you do? And then we joked a lot about what is it you do? It's never been anything been defined. And they kept calling me a consultant, but I really never was a consultant. And that's why it was called Sinclair Energy Services Limited. So anyway, my godson was just come back. He'd gone to engineering school and done quite well in Calgary, and then he'd gone to travel the world to find out what make people happy. And he'd come back, and he was looking for employment. We had him take over what SES was doing. I worked with him, and we did the first few projects together. And then we reversed the process after a year or so, and I did a few projects with him as his employee to give him some credibility. And he learned a bunch of stuff. His thrust is way more towards the environment than energy.
Is Brad? We talking about Brad White?
We're talking Brad White's talking about Scott Sinclair.
Oh, Scott Sinclair. Okay, I got you.
Scott Sinclair, and he's the CEO, and Brad White's the president.
Gotcha. Okay.
So they built SES, so they took over the consulting. And the joke there is I used to go to their soirees. Jane and I ran the thing for 25 years, and the two of us, and they were up to 30 people in a couple of years. And it's like, God, you guys are inefficient. Yeah.
Wow.
So that's where SES came from. They're doing fine and doing some great things, as you see, Brad, and showing up at some of these events. So at that point, at the same time, we were fiddling around with automated buildings. And when we retired, I guess that was the bigger problem. Jane and I were used to working long hours as a consultant, and Jane always worked all the time with SES. It isn't that she was just involved in automated buildings. When she came, she would ask one of the fun stories there is the control valves. So she would say when she was doing a control schematic, she'd said, the ones with the bow ties.
Oh my gosh, that's great.
With the bow ties. What do you want to do with the valves with the bow ties?
That's great. That is great. So you guys have been business partners as well. Then it sounds like if she was with you with SES and automated building, so you guys, that's pretty amazing. You guys can be married and work together so well.
Yeah, you obviously never grew up in a farm community. Everybody does that. The joke, the joke is you either get to drive the grain truck or the combine.
Oh my gosh. That's funny, Ken. That's funny. That is funny. All right. So what gave you the idea for automated buildings?
Okay. So 1999, the internet is starting. I was fascinated by the internet. I'm a technology junkie, as you probably noticed.
Yeah.
So I was just blown away by what was going on, but I couldn't find the Johnson Control site, and I couldn't find the Honeywell site because Johnson was buried under batteries and car seats, and
Yeah.
Honeywell was buried under aerospace.
Yes.
And so I made up a page, the first page, and basically I didn't even have Google back in those days. My daughter was working on LookSmart, which was one of the first search engines before Google. And she was in San Francisco working on that, on the startup, trying to use some of these early search engines. We were able to pull together a first page that had like maybe the 20, 30. It's actually still on the site. Some of the stuff we did were those first pages of just resources of who the heck was on the site. And I just did it because I was interested. And I figured I did a calculation that there's usually about, in the average good-sized city, there's usually like about maybe 50 people that have a clue of what it is we do in building automation industry. And so multiplied that times the amount of cities, figured out there might be 5,000 people in the world that might even understand what this was for. But with the internet, it could actually reach them. So, so pulled this together. And another thing that was going on is we started another company, a Crash and Burn. We were going to, I guess, when was that? That was just after or just before? Yes, before Automated Buildings, we started ESI, Environment Services. And Environment Services was going to bring, it celebrated the remote office and the fact that your life would be on a laptop, and your second car would be a laptop. And I was going to also integrate home automation into the home.
You were just early with that, Ken. You were just probably 25 years too early or 30 years too early. You're the original WeWorks guy.
They still haven't met my mandate.
Well, you know what? You and Jane still got something left. Maybe that's the next project. Show those WeWorks people how to do it.
That's right. So anyway, that kind of crashed and burns. It was not well thought out, and I'm not good on financial models. I'm better on concepts and stuff like that. Yeah. Anyway, that company still owns Automated Buildings, so that's interesting.
Oh, interesting for sure. Yeah, Automated Buildings was the staple. It's just you guys since 1990, huh?
1999. Yeah,
1999. Wow.
1999 is when we started. Yeah,
that's amazing, Ken. That's amazing.
Yeah, so we grew up with the internet there, and the idea of stuff just evolving is a way of life for me rather than being unusual. So this AI thing it's just another step.
Now, where do you see now? Okay, so let's say you and Jane, let's put you back in your mid-20s, but in this time frame, what business are you getting in now if you're in your mid-20s? You and Jane.
Pig farming.
Back to pig farming.
That's where you are, though. But the trouble is, you are what you know, eh?
Yeah.
That first job is huge, eh?
Yeah.
The first jobs you get are they change your life, because maybe not so much for city folk, because you kind of run into that stuff all the time. But when you live on a farm, you're pretty isolated, so you are what you are. But the thing you learn is that you can see the end of every process, kind of thing. Is if you don't have fuel, the tractors don't run. All of the infrastructure becomes cardinal. How does this all work? Where does the power come from? Where do we get rid of this shit? Yeah, it's like all of that stuff is brained on you.
So you learn to think process-wise in terms of complete processes.
And you don't depend so much on other people.
Yeah.
You solve your own problems. And so no matter how automated you can make it, it's okay, now what am I going to do when it all comes apart? Yeah, so some of that. But anyway, so I don't know that. And of course, to try and imagine what's happening now, we have just the people that have grown up digitally connected, they're just completely, they lack the other thing. They don't know how to work a shovel. They don't know how to push a paint. They don't know how to do everything.
Yeah.
Which is scary. And I think we're finding that now as we're getting a lot of layoffs in the software industry is these folks are all of a sudden, they're pretty naked. You mean I can't even work as a laborer? You don't know enough to work as a laborer? Yeah. Which that was always the fallback, because you could always do that. But so anyway.
It's interesting times.
I know I sidestepped that, but because if you throw us back in that time, I guess what you always you want to go back in that time with the experience you have.
No, actually what I was asking you to do was imagine you and Jane are now 25 years old. knowing how you
Okay.
evolve
Yeah,
with
I
the
get it.
different technologies and stuff.
But we get to carry our knowledge with us, or
Yeah, I mean, one of the things I got, Ken, from you and Jane is you guys were really good at spotting the new trend and hopping into it. So backwards way to ask you, if you and Jane were 25, 26 now, with your personalities, and now you are in this environment with all the technology that's available now, where would you go? What business would you guys be creating now if you were, and Jane were now 25 years old in this time period?
That's probably a pretty good question. I think there's a tendency to go towards the data scientist kind of approach and the whole data piece, but in my mind, there's going to be a tremendous backlash to doing what we're doing, which is the nuts and bolts of trying to make this stuff work. And all of this AI, the fact that the AI is going to take over pulling together this data and pulling together how the building operates is going to put even more emphasis on trying to make this stuff work, which is like where we started is it's you're growing up on the farm. If the tractor's broken, you got to fix. That's the job. That's the first job you got to do today is fix the tractor. So you do whatever you're going to do. It's the same thing. Is all these sophisticated tools are going to tell us these buildings are broken. And the stat that came across at the Monday Live the other day was there's 1.4 billion square feet of extra office space. So all that office space has to be retrofitted into probably residential. And then we've got the problem, do folks really want to move downtown when in fact the only reason they were downtown was because that was where they worked, but now they don't work there anymore and they'd rather stay at the lake. And so there's a lot of dynamics going on there. But there's no doubt that no matter what happens, if they end up growing food in the high rise, it's got to be changed if they turn it into a co-op.
What I hear you saying is with all this great stuff like AI that can tell us something's wrong or something, somebody's still got to be able to take the wrenches out and the screwdrivers and fix the hardware, right?
Yeah, no, we're beyond the wrench and hardware stage a bit in the fact that the industry that you and I work in it's the knowledge of knowing if I can use that controller again or if we will just completely replace it. I think the IT approach is a bit utopia. That's not going to happen because of the realities of actually connecting to physical things. We're getting the sense, there's been more evolution in the sensors, but ultimately the valves and actuators and all that stuff haven't really changed that much. So people who have knowledge of how to work those and make all that stuff happen, I think, and that's actually, I can akin that back to the DC. So as I grew up in the DC revolution, everybody was fearful for their job because DC was going to take over their job. Right. DC didn't take over their job. DC made them, we had to hire 6 more people to fix the friggin' system because the DC told us the system didn't work. And we've got 300 boxes that don't work and the pins are dropping out of them. So we got to go back and replace all those pins. Yeah. Actually, one of the compliments I think we got on the Robson Square project is he said, I used to come here and all the service people used to be sitting here in the office. And he said, since you put this system in, I come in, there's never anybody in there. They're always out fixing whatever it told them. They're way down 2 blocks down there because there's a broken box down there. So I think we're just going to see that on steroids with artificial intelligence. Don't quit your job. Don't quit your control job.
I think you're right about that. Ken, as we begin to wrap this up, so looking back, or some of these younger people coming up, could you give them 1 or 2 maybe pieces of advice that are timeless? Doesn't matter whether it's artificial intelligence or you're a pig farmer. This is what's going to have your life work better.
I think mentors. I would have to credit almost everything I've got with the mentors that I ran into and I respected and I learned from them. And there were many, and they're not necessarily smarter than you and they're not necessarily older than you. I put out a concept in the last little while here about encouraging younger mentors, and that's exactly what we need right now. Is we need to have somebody that we trust that we can go back and see the world through their eyes because we've grown up the way we've grown up. And so the mentors have been cardinal in my growth and focus, I think, in the industry. A lot of them are ASHRI folks. I'm past president of the local chapter of ASHRI and also AEE. I was doing that in my spare time while we were doing all those other things as well.
Nice.
I was ambitious when I was young. Anyway, yes. So yeah, mentors, getting involved in organizations, finding people of like mind, but not too like. Actually, that's the problem too. Is it's quite often if you're sitting in a conversation and you're agreeing with everybody in the room, you're in the wrong room.
Yeah. All right. This is Ken Sinclair, automatedbuildings.com. He is still creating value. And I suspect if you had a question for him, he'd probably be willing to mentor you if you reached out to him. And Ken, I can't tell you how much appreciate you coming on and being our guest here on the Legacy Voices podcast.
Okay. Thanks.
Thank you for listening. We hope you enjoyed this episode of Legacy Voices. Subscribe to this podcast and never miss an episode. To get all the control news you can use, including other industry podcasts, please visit us at Controltrends.com.